This is a brief review of the key ideas out of 4.1. The first thing is that you need to understand the difference between an absolute maximum and a relative maximum or minimum. When you're talking absolute, you're talking about the highest y value in a function. So if I happen to have a series of values like this, then I would say that the highest y value is this distance right here, depending on where your x and y axes are. Let's say the x and y axes are like that. The thing we're looking for is the y value, the height. The absolute minimum of this function is going to be all the way over here. And the reason why is because that's the lowest y value. So an absolute or global is always going to be the biggest or the smallest. When you're talking a relative max or a relative min, and this is a relative min right here, and this is a relative max right here, we're going to take this piece and look at it as part of a larger whole. In other words, here's the shape of the curve right there. If you're sitting at this spot and everything to your right and your left is larger or a greater y value, then you're talking relative. Same thing goes if you're talking this region right here. If you take that and label it just like that, put it there. If everything is beneath, then you know you're at a relative as well. This is going to be a relative max because it's higher than all the other close locations. And this is a relative or local min because all of the local values right near it are going to be higher. So that's what these bullets all the way through number 6 are about. The word extrema is simply saying you're at a relative max or a relative min. So critical numbers, that's a really key concept. And you need to almost memorize what's written there because there are two key ideas. First of all, if you're sitting on a function and you happen to be at a relative max or at a relative min, then you could be at a spot that is based on the slope of the line. In fact, you are at a spot based on the slope. So right here, the slope is 0, slope is 0, 0, 0. Right there, the slope is undefined or does not exist. And then right here, the slope is 0. Whenever your function has a derivative that's not defined or is at 0, we say that those are critical numbers. They are x values. So let's pretend this is 3. Let's pretend this is 5. And this is 9, and say this is 12. And then right along here, let's say that that's 13. And then this spot would be 14. Those are all your critical numbers. They are the numbers that create a slope of 0 or an undefined slope. Based on knowing what the critical numbers are, you can then figure out what the maxes and the mins are. What about this does not exist slope? Well, that's going to be a spot that usually is going to be an inflection point. And we'll talk about that more later when you come back. The procedures for finding absolute global extrema, these are crucial, and I'm going to add a 4th star because this is the process. You want to find the critical numbers by finding where the slope is 0 or does not exist, just like we did up here. You want to find the y values of each critical number by plugging those critical numbers. For instance, these critical numbers right here, I would plug every one of them into the function. F at 3, F at 5, all the way to the very last number in the line, F at 14. But there's a little side note. You must check the final endpoint if there's a solid dot there. Let's say this is 15. Let's say that this is an open circle and that's located at 1. I don't have to check this one because nothing is there, but I must check this value right here because the function exists there. So I have to go to F15. After I've gone to F15, I compare all these numbers to decide which one is the absolute biggest. And it's obviously going to be located right here, but you've got to know how high that is at F12. Or what's the absolute lowest? Well, it's going to be right here at F at 9, and that's going to be the y value right there. Know the second procedure, which is to find those y values and the endpoints. And then finally, as I said, choose the least and the greatest. Please make sure you highlight this note down here and notice where I made an arrow, and also notice we're not going to consider endpoint extrema to be relative. The relative extrema are only going to be when you have something on both sides of your extreme point. So this cannot be a relative, this cannot be a relative, and because it's an endpoint, it just doesn't come into play except to evaluate the function at that number, f15, to see if it's bigger or smaller than any other number. And that's the process we'll go through. Good luck with the examples, and if you have any questions, you know how to reach me.